Hello everyone. In this video, I'll talk about how to solve those stoichiometric equations, stoichiometric problems, how to solve for mass, how to solve for number of atoms, to solve for the grams and other units. Before jumping into the problem, I'd really like to explain first the theory behind those units that we commonly use in general chemistry. And I would like to explain it first by just visually showing you some live examples. Let's go ahead and get started. Imagine we have the stack of eggs. Right here, just I draw a stack of eggs. So it's like hundreds of eggs. And what we want to do is we would like to transfer some of those eggs into this box. And then the box contains 1 dozen eggs. So you know dozen, mostly in literatures they write, authors use a dozen means it's 12. So when we want to fill this box, so how many eggs we need? We need obviously 12 eggs just to fill this box. And so it's pretty easy. So we just transfer everything, and now you have in 1 dozen you have 12 eggs, or in the box that you fit the eggs as 12. So now when you want to measure the mass of this, obviously what you do is you're going to put it on the scale. And here I'm going to draw a little scale here. So what you do is you will transfer this whole into scale and then measure it. So when you do it, so it's going to be, just going to write that this is a scale. So it's going to be 12 eggs, roughly 700-ish gram. So now you know that in this box, only 12 eggs contain. And then the mass of these 12 eggs is total 700 gram. So you can easily solve if it's 700 gram is 12 eggs, then for per egg, how many gram is going to be? It's just a simple equation. So stoichiometry works exactly the same. Now imagine you have a pond of water. So here I'm just going to draw. So this is just a pond. It contains water. So now what you're going to do, you want to transfer this water into similar box, but contains only 1 mole. Not a dozen, not 1 dozen, but now 1 mole. So how much or how many water molecule you can transfer from the pond to fill 1 mole of, for example, box. For that, you need 6.022 times 10 to the 23 molecules. That many molecules you need to fill this 1 mole. And now, when you transfer this again into scale to measure the mass, so again we have this scale. When you transfer it to measure the mass, and when you do it, it's gonna be 18 gram. So similarly, just like the top, now you have a pond, and now you transfer it 1 mole from that pond. It's 6.022 times 10 to the 23 molecules, and that's what we call Avogadro's number. And that many molecule will become 18 gram. Very similar to the eggs analogy. So, and then you can write it more easily, so more in a straightforward way. So you can just say 6.022 times 10 to the 23 is equal to 1 mole. And that at the same time equal to a molar mass, because this 18 gram, this is a molar mass of water. This is a molar mass of water. So we can just write m, meaning molar mass. So 1 mole is equal to 1 mole of any molecule is equal to 6.022 times 10 to the 23. And that equal to the molar mass. So instead of water, if you transfer now CO2, for example, here I'm going to write, you have a gas, let's say, I'm just going to write now, not water, now no X, now you have a gas of CO2, and then when you transfer it in some kind of container, just to measure the 1 mole, how much do you need? You need exactly the same amount. You need 6.022 times 10 to the 23. That's the magic. That's the number of CO2 molecules. And then when you try to transfer it to the scale to measure the mass, and then it's going to be 40, I believe it's 44. Yeah, 44 gram. So it's 44 gram per 1 mole, or we can just say per mole. That's where the molar mass came from. So now let's go ahead and solve the real problems. So here I redraw this on top, so we have enough space to solve some equations or some problems. Now let's take a look on here. So here it says 1 mole is equal to 6.022 times to the 23. We can write it as, you say, just an Avogadro, because it's an Avogadro's number, just for simplicity. And that is also equal to a molar mass. So this is kind of standard. So you always have to keep this a little cheat sheet in your mind each time when you try to solve stoichiometry problems. Now let's say, so it is saying that per 18 gram we have 1 mole. If it's 18 gram of water is 1 mole. The question here, what would be per 1 gram? How many moles are going to be per 1 gram? Now we don't have 18 gram. Now imagine on the scale we're going now from right side to left side now. If we have 1 gram instead of 18. So in this case we're going to solve it like that. We have, you write how much it's given to you, 1 gram, and then you've probably seen this, you draw it like that. So 1 gram, and now the question is, okay, so what to put next? So you need to put in a way that your final unit should be in moles. So somewhere here should be end up with moles. So right now you're starting from gram. So that's why you write in the middle, you write 18 gram, just write GR, per 1 mole. Because you have it right here. It's 18 gram per 1 mole. So you just write 18 gram per 1 mole. So now in this situation, in this case, now this gram and gram are gonna cancel. They only cancel in a way if you write it like that. One is on the top and one is on the bottom. So now the rest is just an easy math. You multiply all the numerators and then divide it by denominator. When you do that, you're gonna get, just gonna quickly calculate it. 1 divided by 18 is gonna be 0.056. So, and it's 0.056 gonna be mole. So I'm just gonna rewrite here properly. So 0.056 gram or gr. So this is how you're not gonna write anything here, and then definitely not gonna write anything here. So when you have this kind of equation, you always need to cancel those units. So that's why unit is very, very important. Now let's solve a different problem. Now let's say we have, instead of right here, instead of 6.022 times 10 to the 23, which is Avogadro's number. Now, what if we take only 1.22 times 10 to the 23? So now here I'm going to write for clarity. I'm just going to erase this. Now, instead of an Avogadro, now we're taking only 1.22 times 10 to the 20, let's say it's 20, not 23, but 22. Now we have this amount. So, in this case, now it's not going to be 1 mole. Now it's going to be how many moles? So I'm just going to write, and then how many grams when we convert it into gram. So I'm just going to write like this. So how many grams is going to be? We know that when we take the Avogadro's number, there's going to be 1 mole in the box, and that will exactly same as molar mass. But now we have a different number here. So let's try to solve this one. So again, we're gonna first convert it into mole. So you know the unit of this is molecules, because it's a number of molecules. So always remember, writing unit is the most important, because then you need to cancel out, and then you just put the slash. So now you need to first convert it into mole. For that, you know that your final answer, you're not going to write anything here, your final answer should be mole. So some x mole. So that's what your final answer should be. So now let's solve it. For that, again, you need to write down in the middle in a way that molecules, the units should cancel out. That means if you have molecule here, molecules, and you have to have a molecules right here as well. And then what you need to put here, it's your standards. That's on the bottom, it's gonna be your Avogadro's number, 10 to the 23 molecules. So then on top is 1 mole. You should know from right here. So 1 mole is equal to that amount of molecule. So that's it. So once you solve it, the molecules and molecules cancel out, and then you end up with having mole. And when you calculate this, you should be able to get, let me erase this, you should be able to get 2.06 times 10 to the 44 moles. That's how important the units are. Now let's take a look, how can we convert now from moles to grams? Because here we found our moles, and now we need to find that many moles, that much moles, 6.02 times to the 44. how many grams they're going to be when we measure it on the scale. Okay, so here I wrote the equation on top, so make sure I have some space. Next, what we need to do is going from this mole, to gram, because remember we solved this. This will be here instead of this. I'm just gonna write 0.2.06 times 10 to the 44 moles. Now we have to go how many gram it's gonna be from this mole by given a specific mole. So we can rewrite this times 10 to the 44 mole, and now we have to find how many gram it's gonna be. So I'm just gonna write here, there should be a X amount of gram. So we have mole, we have to go from mole to gram. So remember, for that we need to have something mole on here, and on top of it we should have gram. So what we're gonna put, so always remember here, so in this area you always put what you have right here in a standards. So in a standards, according to this, is 1 mole is equal to the molar mass, which is the gram of it. So it's, if it's water, then it's going to be 18, because remember the H2O, I'm just repeating, is equal to 18 gram per mole. So this is the molar mass of H2O. So always remember that. And so that's why we're gonna write here 18 on the bottom. It's gonna be just 1 mole. And then when you calculate this, you should be able to get and I'm just gonna trying to write this as clear as possible. So it's gonna be 3.708 times 10 to the 45 mole, gram, because mole and mole will cancel out each other, just like here, molecules and molecules cancel out, so mole cancel out, and then we have a gram here. So this is how you solve stoichiometric problems.